I'm Paul North, and I want you to meet the ocean.
Meet the ocean!
Today's episode is about killer whales. Killer whales. Now, they might be the biggest, baddest carnivore in the ocean, but there's still a lot for us to learn about what they eat and how they live their lives. Luckily for us, we got a great lineup of people, chief among them Dr. John Durban and Dr. Holly Fernbach, who probably know killer whales in Antarctica better than some of us know our own families. The interview you're about to hear was recorded just a wee bit north of the Antarctic Circle. It was in January 2016, and we were headed down the west coast of the Antarctic Peninsula. On board were John Durban and Holly Fernbach, two NOAA scientists on the front line of marine mammal research, and they were there in search of killer whales. Of course, I wanted to know how someone pursues such an amazing career, so I asked them.
Well, I was pretty lucky. I started studying killer whales when I was a teenager. I won an essay writing competition, and the prize was to go on an Earthwatch expedition, and I chose one in Washington State that studied killer whales, and so this is where tourists are placed with scientists and learn about science and help, and I first went there when I was 15, and I'm still involved in that study today, over 20 years later. So that's awesome. There's been a lot of lucky breaks along the way, but we're lucky to do something that we love doing, and that's researching killer whales.
And what about you, Holly?
Similar to John, I started very young. When I was in high school, I went down to a marine biology camp down in the Florida Keys, and I saw my first wild bottlenose dolphin, and I said, that's what I want to do, go to university and study that. So I went to University of North Carolina at Wilmington, studied marine biology, and started on a bottlenose dolphin project there my first year, and I've been going ever since.
Well, we study top predators, and the ocean's top predator is a killer whale. We also study other large consumers in the ocean, like blue whales and gray whales. And we're interested in how predators affect the ecosystems they're part of and how those ecosystems affect the predators. In many ways, they're like a canary in the coal mine. If we can study these predators that are fairly easy to see, we can understand a bit about how the whole ecosystem's working and how healthy it is. So we study killer whales and other whales both close to home in California and around the world. And this is killer whale central. Antarctica has more than half the killer whales on the planet. So if we're trying to study the effects of top predators on an ecosystem, this is the place to do it.
Here it comes.
There are 5 different ecotypes of killer whales that you can find in the Southern Ocean. 3 of them are the types that we're going to most likely see down here in the Antarctic Peninsula. And those 3 types are type A, that primarily feed on minke whales, and it's, as you mentioned earlier, it's the largest form of killer whale that you can find around the world. And then there are 2 different types of B-type killer whales, one that we call the B1s that like to wash the seals off the ice, and then another type that we actually saw yesterday that they take penguins. And then one of the big questions that we're trying to answer while we're down here is what they're doing when we found that they make these deep dives down to about 700 meters of what they're feeding on at these depths. And the 2 other types, one of the types occurs in the Ross Sea. It's the type C killer whale. It's the smallest form that's been described in Antarctic waters. It takes fish, primarily toothfish. And the 5th type we don't really know that much about. It's the type D killer whale, and a lot of what we know about it is just from photos that have been taken from like we just did a couple days ago going across the Drake Passage. So we're trying to learn more and more about that, probably or almost certainly future species, but the 5th ecotype down here.
What I found incredible was being out in the Zodiac with you guys yesterday, and we ran into a pod, and you had such a sense of familiarity with them, claiming that you knew them, you had spent time with them before, and even recognized either some of their physical features or perhaps the shape of their dorsal fin, which speaks to the years of research that you guys have done.
Yeah. Killer whales are much like humans in that they're long-lived. They live about as long as we do. And they're creatures of habit. So what that tends to mean is we see the same killer whales returning to the same place year after year to do what their mothers did and their grandmothers did and their great-grandmothers did. In fact, they're traveling the same groups with those older animals. So the group we found yesterday, a group of B2s, we call them Gurlash Strait killer whales, and we found them in the Gurlash Strait yesterday. We've seen them for, 4 of the last 6 years pretty much in the same place, and we recognize the individuals by marks on their dorsal fin and their saddle patch, characteristic pigmentation patterns, and it's not really a surprise that they're in the same place because this is where they've learned how to hunt and how to feed, and that's really the stock in trade for how we do our research, is recognizing individuals, counting how many individuals are in the population and how the population's doing. So it's pretty exciting to see them. It's like old friends.
You don't need to live close to the ocean to ask questions about it. So here's my friend Meg and her 2 young sons in Phoenix, Arizona, with plenty of questions and knowledge about killer whales.
Hi, Paul. You guys say hi.
Hi. Hello.
So we're sitting here at our table in Phoenix, Arizona, which is not very close to the ocean, but we really like the ocean at this house. And we're going to talk to you a little bit today about
Killer whales. Killer whales.
killer whales. Sitting with me is
Colin.
and Ezekiel, and they're going to tell us what they know about killer whales and what they think killer whales do all day at the bottom of the sea.
They're part of the dolphin family, and they are found in all parts of the ocean. Killer whales are not known as human killers, but there has been a couple dangerous killer whales that have killed or injured their owners.
And why do you think that they hurt their owners?
Because they don't like it, and they want to be in their normal habitats.
That's very true. What do you think killer whales eat, Ezekiel?
Anything that lives in the ocean.
Anything that lives in the ocean.
They usually just eat seals, dolphins, maybe small stuff that's swimming around the
I thought they
ocean,
lived
and
with the
just
dolphin family.
simply crawls into their mouth.
Easy, what do you think killer whales do all day in the ocean? Sleep and eat.
Hunt, sleep, eat, and fight.
Any other interesting facts?
Hello.
The white spot, that looks like where the eye would be, but the eye is actually somewhere else.
Oh. Thanks, Paul. We'll talk to you soon.
Well, I hope you all learned something, because I sure did. Now let's give it back to the experts, Dr. John and Dr. Holly. In my mind, you guys are kind of leading the charge in terms of aerial science for marine mammals, which grateful to have you here with us on the ship right now and in the scuba layer on the National Geographic.
We're not allowed in here very often, so this is a privilege for us.
Yeah, we actually have a sign-out sheet for tools that you'll be using later on. So something that is very new and very interesting, not only to science in general, but also to the people witnessing it on board, is what you've brought on, which is a hexacopter. And I believe this hexacopter has a name?
Chimo.
Chimo. And where did the hexacopter Chimo get its name?
A killer whale, an albino killer whale, actually was named Chimo. So it was a completely white killer whale. Actually, it had
Shigeaki syndrome.
Yes.
Shigeaki syndrome. This is a killer whale known from around Vancouver Island in the 1970s. It didn't live to see adulthood, but it was a white killer whale that had a syndrome that made it white. And our hexacopter has a clear dome on top of it, so it reminded us that it's whiter than our other hexacopters, so it became Chimo. Our hexacopter, which some people might call a drone, is just a small unmanned aerial vehicle, about 32 inches wide, only a few pounds in weight. And its sole purpose is to carry a camera to get it above the whales, not very low above the whales, but over 100 feet, so they don't notice it, and collect images that measure size and shape and how they're growing and how fat they are. But we've also used it to collect blow samples from large whales, blue whales and humpback whales. And so we fly low, they still don't notice it, and we collect blow samples. As they exhale, we collect whale snot, and we collect it on a sterile plate, and we can do DNA work to amplify virus and bacteria from that. So we're asking two very simple questions. We're photographing them to see how fat they are, and we're collecting pathogen material from them to see, to ask the question of what might be causing them to be in different condition, if they've got emerging disease issues. And boy, you know, it was only a couple of decades ago the only way to study whale health was to kill whales and put them on a whaling slab on a whaling platform or on a ship. Now we can assess their health and condition by taking a photograph of them. It's pretty cool.
Probably the most exciting thing about the aerial work both from the helicopter and now from the hexacopter, is that we can look at the individual quality, not just quantity, like you were saying with numbers, is that we can actually say this animal's growing like it should be growing, or this animal's as fat as it should be. We can tell if an animal's pregnant, and then we can see when the animal shows up after they should have given birth, if they have a calf. If they don't have a calf, we can look at reproductive failure. So it's something that helps us, it provides us with insight that we haven't been able to obtain before, with amazing resolution of the photos, and it's just taken our research to a whole new level.
So the key thing with a hexacopter is we want to maximize flight time, so we want to keep weight down. So we carry a mirrorless camera, an Olympus Micro Four Thirds camera that's high resolution, 18 megapixels, but is pretty light and small. But the key thing with it is it has interchangeable lenses, so we can have a relatively long lens, and that means there's no distortion in the image. It's what's called a normal lens, and that the image is flat across the whole thing. So we can measure from pixels and extrapolate the real size of the whale. So we fly that camera high because we've got a long lens, because we want to fit the whole whale in the lens, and in the frame, and that allows us to measure. And it's great. So from an altitude of 100 feet, our error in measuring the size of a whale is just a couple of centimeters, and I think that's amazing. We had a colleague that's been involved in marine mammal research for 40 years, and he said, look, if you had a dolphin on the deck of a boat, you couldn't measure it with that precision with a tape measure, and we can do that from a camera without ever touching the whale.
I'm about to crack my 50th dive down here.
Whoa,
Wow.
okay.
So, and several hundred in Alaska, and yet no killer whale encounters.
You're probably happy about that, or you might not make 51.
Yeah.
It's probably my.
They'd be scared of you, Paul.
It's
Yeah.
my cologne or something.
Yeah.
And the leaky glove.
Killer whales are creatures of habit. Although they might check you out, they'd swim away pretty quickly. They've learned from their mothers and grandmothers what they need to eat, and the little guys might check you out, but the big guys won't be interested.
Though I haven't had any underwater encounters with killer whales, I have had plenty topside, and none will beat my first time in the waters of Alaska.
You don't forget the first time you see a killer whale. It kind of hits you over the head. For me, it happened in 2010. I was on a small 51-foot boat, which was a commercial seiner, up in the Prince William Sound in Alaska. It was my 4th year working as a commercial fisherman, and arguably one of the best. But the season was over, it was time to go home, and that meant crossing the Gulf of Alaska. It's about a 22-hour run, and it might be on the northern edge, but that doesn't mean that it's any nicer. But for some reason on that day, clear skies, calm water, not a whitecap to be seen. So of course I'm up, outside, sunglasses on, reading my book. And then I hear my captain make a noise. It wasn't a scream, it wasn't a grunt, it was just a noise, kind of like a hey. It's just the way he communicated. He wanted us to see what he was seeing. So I climbed down the ladder, I grabbed a pair of binoculars, and sure enough, in the distance, heading right towards us, was a grouping of killer whales. How do you know? Well, you look, and you see that large dorsal fin sticking up. Those are the males, of course accompanied by females. I didn't know anything about them back then. I didn't know that it was Mom who ran the show, and maybe Grandma before that. I didn't know how they operated. I just knew that they were heading towards us. I ran outside, and I just started climbing. I wanted to get as high as I could, because if they came as close as it looked like they were going to come, then we were really going to see them. So my captain dropped the throttle down to an idle, just kind of edged forward, letting them approach us so that we wouldn't spook them away. And they came so close that the largest male went right under our boat. He turned in cold, clear water, and I saw its eye looking back up at me. They didn't stop, they didn't circle us, they just wanted to get close and understand who we were as they passed. And every man on the boat that day will never forget it.
The key thing with the hexacopter is that, if you look thinking just in terms of battery life, 4 motors are the most efficient. They give you stability and they don't draw as much battery. But 6 motors gives you that redundancy, as Holly said. But it also means that each motor and each propeller can be smaller. And that's really important when studying wildlife, because it means the hexacopter is relatively quiet. You would have heard that yesterday. You were driving the boat, but I could still talk to you when we were taking off and landing. And that's really important when studying wildlife, because we want to be non-invasive. Once it gets up to 100 feet, you can't hear it, and the whales don't know it's there, and that's really important. Battery life is 10 minutes to 25 minutes, but we've got multiple batteries, so we can bring it down safely, put another battery in, and go again. And that's very different to our work previously with conventional aircraft, whether it's a helicopter or a fixed-wing aircraft, where you're paying thousands of dollars per hour. You have to have a pilot on standby, and that's just not cost-effective in a remote environment like this. And it's unsafe for scientists to fly in remote environments with bad weather. So now we have this tool we can take out on a small boat, wait for the weather to get good, and when the whales are there, and fly as much as we can, and the only cost is charging batteries. So that's really valuable, both in terms of safety and non-invasiveness for the whales and the effectiveness of our science. So, boy, it's exciting times to do this.
Here it comes. Whoa!
One of the reasons we're interested in killer whales is they have remarkably similar lives to us. They're long-lived. They might live as long as we do, or longer. They don't give birth to their first calf until mid-teens or late teens, much like us. The females keep giving birth until their early 40s or so, much like us, yet they live twice that long, much like us. And so I think we can relate to this family life and the value of having grandmothers and great-grandmothers around us. And boy, it's an amazing way to do this, and understanding that they have longevity and memory and culture makes a lot of sense.
They stay with their families their entire life. So they're still traveling with the grandmothers and the mothers and the aunts and the brothers and the sisters, and it's quite a remarkable thing. And one thing with killer whales that's very different from a lot of other mammals is after the age of about 42, the females stop giving birth. But then they could live to be over 100. And so then you have these senescent females that are there only to help feed the other members of this family unit. And if you have a sick animal, then they'll bring the other animal food. If you have a pregnant female, like we just saw this past summer with a really dependent calf, and they can't go out and forage on their own, you'll have other members of the pod bring them the fish.
So one of the challenges if you live in your family group the whole life is, how do you mate with an animal that's dissimilar from you? How do you avoid inbreeding? And killer whales do it really well in that they select mates that are genetically dissimilar from them. And they probably do it by dialects. They have acoustic dialects that correlate with genetic relatedness. You sound like your mother.
John and Holly might be the experts, but you don't need a PhD to get excited about killer whales, or even to know a few things about them, as our young friend Josiah from Chicago, Illinois proves.
Hello, my name is Josiah, and I know some things about orcas. I know that spy hopping is very usual for orcas to see what's above the water, and I learned this in the show Octonauts, and it's really fun too. There is something else they do. They also do ice tipping. It's when they ran into ice floes, and they keep on doing it until their food falls from the ice floe. But when the ice floe doesn't go deep down, it'll be really hard to actually get food that's up. So sometimes they usually spy hop under the ice, the thin ice that has seals on it. They go under it and they sneak up under it, and then they ram it at the bottom. Sometimes the ice will break up, or it will just go flying.
Whales.
It's really impressive because you have that food sharing within all of their types. So whether they feed on marine mammals, or whether they feed on salmon, whether they feed on penguins, then you see this sharing between all of the animals, and it's quite remarkable.
Yeah, it's probably a huge part of what they do, and that if you live in your family your whole life, it benefits you to not only feed yourself, but help your relatives. I mean, that ultimately helps your genes being passed on if you help young males and young females who are going to reproduce for many more years than you are. It's very interesting with killer whales that the males are much bigger than the females. They have big appendages, big dorsal fins, big pectoral fins, big flukes, and that's not to fight. It's to actually show quality. They're like a peacock. They advertise quality over other males so that females might choose them. And the downside is that they're not very good at swimming or swimming fast or chasing food. And so other members of the family, like females, are better at catching food, and they might help feed these males so that the males might have a better chance of attracting mates and breeding. And this just shows the advantages of living in family. And Holly's dead right, they do family better than we do, and it benefits them very well. Over the last 5 years working on this ship, supported by the National Geographic Society and Lindblad Expeditions, killer whales weren't thought to be very deep divers. They were thought, for example, most of the information on killer whales came from the Northeast Pacific, where they feed on salmon. So it was thought they might dive to a couple of 100 meters, but most of the time they were surface dwellers. Well, now we know that killer whales in Antarctica can dive to several hundred meters. They can dive for 15 to 20 minutes, and they regularly do that for multiple hours, maybe 8 or 9 hours a day, and then they rest and they do it again. So they're incredible athletes. We've been doing similar work in different parts of the world. Off Western Australia, we've documented a dive over 1,000 meters. In Alaska, we've documented, Western Alaska and the Aleutian Islands and towards Russia, they're diving 500 or 600 meters. So by having new technology like satellite tags that record depth, we've been able to document that they can dive incredibly deep as well as swimming fast, and they're incredible athletes, and that means that as predators, they're unrivaled. They have to eat a lot, but they're fast, they're powerful, they work in their family groups, they've got big brains, and they can dive as well. And we're now understanding why they're such effective predators.
I remember reading a comic book when I was a kid. It was Wolverine, and someone asked him what he does. And his response was, "I'm the best at what I do, but what I do isn't very pretty." Now, killer whales are the best at what they do, which makes them an apex predator. Now, what is an apex predator, you ask? Well, let's find out.
Apex predators are at the top of the food chain. Don't know what that means? Well, let me explain. A carnivorous animal who eats lots of prey, but no one can hunt once grown any day. They are kings of the forest, the sea, and the plain. To trouble these beasts, you must be insane. What? List a few? That I can do. First, there's the shark, of whom's teeth are sharp. They feast on prey in the sea, might even eat meat. Sharks are notorious, they strike in most fright. Watch out for those sharks, 'cause they sure can bite. The ruler of the north is the polar bear. If I were to see one up close, it'd be a scare. They're semi-aquatic, can swim to find seals. Their homes are melting, sadly for reals. Another apex is the lizardy alligator. If I were a fish, I'd certainly hate her. Gators may look nice, but don't try to shake its claw, or its sharp, open mouth could be the last thing you saw. An orca, or blackfish, also called a killer whale, has an incredibly smart alpha predator tail. With sophisticated hunting techniques and behavior, staying out of their way will be doing yourself a favor. And the balance of nature relies on these beasts. Without them in the ecosystems, all would be hurt, great to least.
For those of you who don't know, that was the poetic workings of one Charlotte Fisher, Colorado resident and world explorer. If their flying hexacopter or personalities haven't won you over yet, consider what John and Holly do. In these very remote places, they are searching for answers. Because even though we know killer whales at the surface, what they do below still remains much of a mystery.
It's an incredible mystery that we've got several hundred killer whales here on the west side of the Antarctic Peninsula that we know dive deep. These are these type B2 killer whales. And we know they have to eat hundreds of pounds per day. So they have to eat tens of thousands of tons of food a year for that population. But yet we don't know what it is. So they're removing from this ecosystem the equivalent of a large-scale commercial fishery. And we still don't know what they're eating. And our ultimate goal here is to understand how all parts of this ecosystem fit together. We want to know how the climate affects primary production and how that affects all levels of the ecosystem. We want to know how much krill, large whales and seals remove from the system, and then ultimately how these top predators like killer whales and leopard seals, how those affect the ecosystem from the top down. But yet we've got the largest abundance of the largest predator in Antarctica, the most abundant predator on the planet, and we don't know what they're eating. So our research questions are simple, but they're difficult to get at. So we have to use new technology to ask very simple questions.
And we've conducted dietary analyses on the blubber samples and skin samples that they've collected here, but they could just take it to a certain level of they're feeding at a certain trophic level, but they can't identify exactly what they're feeding on. So what we're really hoping to do is get a clear image, and then we'll be able to see, is it squid, or is it some sort of ice fish or toothfish or something. So that's what we're really hoping to capture.
We believe that this is a species of ice fish they're feeding on, which is important because there are commercial fisheries for large fish in Antarctica, like toothfish in the Ross Sea, and ice fish, nodothenids, have been fished for in the Gurla Strait before, where we find these killer whales. So this is very important for understanding the effects of fisheries on this system that's changing so rapidly with climate change. So we've got to understand how these trophic links, how predators are living in this system before adding another predator, which is us, so we can manage it sustainably. And that's really our interest and the interest of the agency we work for. We've got to piece this all together so we can try and be as sustainable as we can moving forward. We've got a great anecdote that tells you a lot about killer whale society. And a couple of years ago on this ship, we were giving a lecture about killer whales, and an elderly lady in the back of the crowd put her hand up and said, I've just got to check a few things here. She said, so these big males, they travel in their family group their whole lives. They live with their mother. In fact, she feeds them most of the time. I said, okay, yeah, that's pretty much true. So when they find an attractive female, they kind of get together with her for maybe a couple of hours, and they have their way with her. And then they go back to their mother, and they leave the female, and the mother feeds them, and they go off with her. And I said, yeah, that's right. And she said, that's just like Italian men. And this lady was Italian, but she got it about right. And not that these killer whales are doing a disservice to to the males or anything else like that, but just that they have a strategy that they grow big by being fed by their mothers and by living in their family group, but they have to mate outside of their family group, and that's the way killer whale society exists. And the fact that there are some similarities with some of our cultures make them fascinating. I think it's really important to acknowledge that this is the 6th year we've been hosted on board the National Geographic Explorer. We're hosted by National Geographic Society and Lindblad Expeditions, and they've been hugely supportive. And I think this is the way we need to do science. We don't do science in isolation from the public and other stakeholders, and this is a great collaboration. We conduct science along with guests who are coming here to witness an incredible environment, with folks that are the world leaders in ecotourism that are bringing people here. And we're all stakeholders. We all have an interest in the world and the climate and this amazing ecosystem. And scientists don't work in isolation. We've got to do this together with the people that enjoy it and the people that use it, and we're all in it together. So I think it's a great collaboration, and we're really here because of the foresight of these groups that host us and the guests that are on board that help. And I think it's a fantastic collaboration, the way science should be done.
You just really can't stress how important it is to continue this citizen science, because we've actively been coming down here for 6 years, but we have photos dating back for 20 years that we've been able to collect from naturalists and other scientists that have been coming down here.
I think the cool thing is that science can sometimes seem complicated to the general public, and we use complicated tools, whether it's genetics or satellite tags or a hexacopter, but really what we're doing is learning about whales from photographs with really simple questions. Can we identify whales based on their pigmentation, or can we tell how fat a whale is from its shape? And this is something that anyone can relate to. You look at a picture of a whale and we can explain to them, look, this is a fat whale, or this is the same whale we saw last year. And it's a great example that science doesn't need to be complicated to be powerful. And that message is really important for getting public buy-in and involvement in science. And I think that's the way we need to move forward. If we can make science transparent, then everyone's a scientist.
Well, there's our killer episode about the largest dolphin species on our planet and some scientists who have dedicated their lives to know them. If you want to learn more about killer whales, or specifically John and Holly's research, or just have questions about the ocean in general, check out meettheocean.com, where we have videos, a blog digging deeper into these experiences, and photos for sale to support the project. I'd like to thank Colin and Ezekiel for their killer whale knowledge, Charlotte Fisher for her poetic contribution, and of course Tom Szymanski's first graders in the Walt Disney Magnet School in Chicago. If you have a question or would like to contribute to an episode, feel free to email us at meettheocean@gmail.com. Remember that all your smartphones out there have the capability to record at broadcast quality, so all you have to do is speak into your phone and email it to us, and we will address these questions in episodes yet to come. Until next time, may the salt water be with you.